Good day, guys. You are welcome back to Idowu Maths class. Today, we want to consider measure of central tendency of grouped data. Don't forget that we have done that of ungrouped data. Today, we want to consider measure of central tendency of grouped data. Don't forget, under this, we are still going to look into mean, median, mode, and those are the regions of measure of location. So we are going to use past questions throughout this session, and because of that we may not be able to take it mean, median, mode. Any question we come across first we treat, but definitely we are going to deal with mean, median, and mode in this section. Example number 1. This is one of the past questions of the UTME mathematics. The table is given. The question is find the median, that is from the table. How do we say a particular data is grouped? How do we know a group data from an ungrouped data? A group data will have class interval. Wherever you see 1 to 5, 6 to 10, something like this. It may not necessarily be 1 to 5 in another question, but wherever you see something like this kind is what we call class interval. And any statistical data that includes class interval like this is a grouped data. Do you understand? So that's the way to know that we are dealing with group data. Now, dealing with group data, there are certain things you must know before you will conveniently solve the problem of median, mode, even mean on group data. Number 1, you must understand the components of the class interval. Look at this column, we call it class interval. 1 to 5 is a class interval. 6 to 10 is a class interval. 11 to 15 is a class interval. Don't forget, I want to teach you, I'm not just going to solve the question and go and run away. No, I will use this first one at least to give you the nitty-gritty of what we do there. After it, we may now be moving faster than this, but let me use this to teach you and clarify issues. Now, the right side of the interval is what we call upper class limits. Upper class limits, don't forget. While the left side of it is what we call lower class limits. We call it limits. Now, how do we create boundary? Because in this regard, we need boundary. How do we create boundary? When your limits are whole number, as in the upper limit, the lower limit, when they are whole number, the boundary will be formed using the boundary coefficient of 0.5. We subtract the same 0.5 from lower limit. Whatsoever you get is your lower class boundary. Please don't forget that, very important. And that 0.5 will be used if and only if your upper and lower class limits are whole number, not decimal. When we come across the decimal one, I will teach you what we do on decimal. So for whole number, it is 0.5 that we use to make our boundary. Subtract 0.5 from lower limit to give you lower class boundary. Now let's go. For median, how do you find median? We use formula definitely. The formula to calculate median on group data is L1 plus N over 2 minus CFB into C divided by FM. What does this mean? Please try to understand the codes. L1 is lower class boundary of the median class. It is not only in median that we use L1. We use it in mode as well. But if you use it in mode, it will be of the modal class. Now that we are using it in median, it's of the median class. Don't forget. Now, let's come to it. We are looking for L1, which is the lower class boundary of the median class. Come to the table. How do you recognize the median class? Add up the frequency. What you have learned in the ungrouped data is transferable to this place as well. You apply it in. Addition of the frequency, if you look at it, 2, 4, 5, 2, 3, 2, that's 20. Addition of this frequency is 20. Half of that 20 is 10. So add up from here now. Look for 10th position. 2 plus 4 is 6. 6 plus 5 is 11. That means your 10th position is achieved here, meaning that this range 1 class is our median class. Do you understand? If you know that this is your median class, what now is the lower class boundary of that median class? You look for the lower limit first, which is 11. How do you create boundary? As I've taught you now, you use 0.5, which is the boundary coefficient for whole number limits. So you subtract that 0.5 from 11, you get 10.5. That is your lower class boundary of the median class, because this is the median class. Don't forget, this is the median class. So what is n? N is the same thing as the summation f, total frequency. What is the total frequency here? That is 20. 20 divided by 2, that is 10. You can see it is very simple. Now, CFB is a code. What does it mean? Cumulative frequency before median class. That B means before median class. What is the median class here? The median class is at this level, is here. So what's the cumulative frequency before median class? Cumulative means addition. So the addition of the frequency before we get to this median level is 2 plus 4, which is 6. So CFB is 6. The subtraction there is 6. What is C? Your C is what we call class size. Class size. Class size is denoted in JAMB exam. This is what I will teach you straightforward. In WAEC is another thing. We have to find the difference between a particular class boundary. But here, straight away, I will just tell you, subtract this upper limit of the first class from the upper limit of the next class. 5 from 10, you have 5. So 5 is our class size. Do you understand? If you do it even for the lower limit as well, you get the same thing. Subtract 1 from 6, you get 5. 6 from 11, you get 5. 11 from 16, you get 5. Wherever you go, just one upper from the next upper, one lower from the next lower. So divided by FM. What is FM? FM is the frequency of the median class. Just the code is simple for you to remember. What is now the frequency of the median class? This is the median class. Range here. What is its frequency? 5. So you have it like this. Look at the arithmetic you want to do now. You can see that this 5 cuts this 5. No stress. 10.5 plus 10 minus 6. That is 4. Addition of 10.5 and 4 gives you 14.5. So 14.5 is our median value, which tallies with option D. Example number 2. The table is given and the question is, estimate the mode of the distribution above. How do we estimate mode? It's by formula just like that of median. Mode equals L1 plus dB over dB plus dA into C. Let me briefly explain the codes. L1 is the lower class boundary of the modal class, just as L1 in median is lower class boundary of the median class. So L1 is a general term which could be used for median, for mode, or any other thing. But if we are dealing with mode at a time and you have L1, then that L1 is for modal class. Just as this is L1, which is lower class boundary of the modal class. Now, let's come here. How do you recognize the modal class? Modal class is the class that tallies with the highest frequency. Highest frequency here is 27. The class that corresponds to it here is what we call modal class. I hope you understand. Now, what is the lower class boundary of the model class? Lower class boundary of the model class is 10 minus 0.5. It is 0.5 that we use to create boundary for whole number limits. When you have class limits that contains whole numbers up and down, so you use 0.5 to create boundary. So subtract 0.5 from 10, that gives us 9.5 plus. Now, what of dB? What do we mean by dB? The code dB is the difference, D for difference between the modal frequency and the frequency before it. This is the modal frequency. The highest frequency is the modal frequency. So, difference between that modal frequency and the frequency before it. The frequency before it is this 10. The difference between 27 and 10 is dB, and that is 17. So we have 17 over 17 plus, because dB up, dB down. Now, what of dA? That is difference between the modal frequency and the frequency after it. What is the frequency after this modal frequency? That is 19. The difference between 27 and 19 is 8. So, what of C? C is the class size. Class size, as I've explained to you in the first example of median, class size is the difference between a particular class limit and the next class limit, whether upper or lower. This is what I mean. This 10 is upper class limit of the first class. Subtract it from the upper class limit of the next class, which is 20. The difference is 10. 10 is the class size. That is how to briefly deduce your class size in exam. So, evaluate this to get your mode. That is 9.5 plus 17 times 10, that is 170. Divided by 17 plus 8 is 25. So we have mode to be equal to 9.5 plus 170 divided by 25. How many 25 do we have in 170? We have 4 25s in 100. In 150 we have 6. So in 170 we have 6 point what? It remains 20. So you put 0 at the back of the 20 to form imaginary 200. So how many 25 do we have in 200? That is 8. That is 0.8. Do you understand? We add together this and this. 9 plus 6, that is 15. Plus 0.5, that is 15.5. Plus 0.8, that is 16.3. 16.3. What unit are we using there? Gram. 16.3 gram. So our correct option is option C. You can see. Correct option here is option C, 16.3 gram. Let's consider example 3. We are given this table. It's another past question. Find the mean of the distribution above. What's the mean of this distribution? You quickly form a small table. We have class as given. Then, with that, we create what we call midpoint value. Midpoint value, which represents X value in this regard. And after that, your frequency. After that, Fx. Frequency times X value. Our X value here will be the midpoint value. So, let's include our class interval now. 4 to 6, 7 to 9. This class interval 1 to 3 will be used to form our class limit. And how do we form class limit? You find the mean of the limit. What do we mean by mean? When you want to find the mean of certain value, you add them together, divided by their number. So 1 plus 3, that's 4, divided by 2, that is 2. 4 plus 6, 10, divided by 2. Why do we divide by 2? Because they are 2. The number of them is 2. So 1, 2, 2. So divide by 2. 4 plus 6 is 10, divided by 2, that is 5. That is midpoint value. 7 plus 9, 16, divided by 2, that is 8. That is X value from the group data. Anytime you are given group data and you need to create X value for mean, that is how to create it. You find the average, the mean of the class limits. So this is our X value. Our frequency has been given before as 5, 8, and 5. So what is fx? Fx is frequency times X value. Frequency times X value, this is 10. 8 times 5, 40. 5 times 8, another 40. Now, our summation fx, that is addition of fx column, is 90. Look at it very well. Our summation f will be 18. Addition of this. Therefore, our mean equals summation fx over summation f, which is, what is our summation fx? Summation fx is 90 divided by our summation f is 18. 90 divided by 18 is 5, and that tallies with option C. Option C is our correct option.